Hi class, I think we are ready to do this. So we are going to remove a node from linked list. Let's say we start from here, 8, 9, 10, easier to manage. We are going to remove one of the nodes. Of course, we have to take care of all cases, right? So the function will actually return true if they can find the target data and was able to remove it. Otherwise, it will return false. And head is passed by reference. Apparently, we are going to change the there's a possibility that the head will need to be changed. For example, when the first node is being removed. So let's see how this works interactively. So let's pick the easy case first. It's something in the middle. The data 9. So I realized it needs 2 pointers. One is the one that keep track of the one that we want to remove, the node that we want to remove. But because we need to set the next of the node before to point to the node after, and therefore we have to keep track of the node that is before so that we can get the value of next and set it to the one after 9. So this is what we do if the nodes are in the middle. It's pretty simple. So now since 8 is pointing to 10, the node, so we can just delete discard and remove this node and everything is fine, just like we want it to be. What if we want to remove a node that is at the tail? Let's say we want to remove 10 in this case, and we check that, hey, 10 is this node is the one that to be removed. So would that be a problem? So our mechanism in the last case where the data is in the middle, what we did was to have the next that is point to by before. Yes, that is point by before. Have it point to the one the node to be deleted is pointing to. So here it means that we want this to point to where the next node is pointing to, which is actually no pointer. And so no problem, right? So we can just then delete this one, doing a delete discard, and everything is fine. What about if the node that we want to delete is at the beginning, the first node? It looks like the algorithm that we were using would not work because discard always start from this one, right? Because there needs to be one that keep track of before. So it seemed like the first node is a special case, so we need to treat it differently. And we would just point this card to it, and then have a head change to point to the one afterwards, and then we would delete this card, and seems like things will be working. It's just that we will pass a different value of the head pointer back outside of the function. So let's go back. So let's then look at our not so detailed plan. I realize it's too many details to put into a plan. I think when I write mechanism, I don't always put every step. So this is one of the case that I feel like a general idea of how to do this. And then I would write according to this, not every single step plan. So the plan is if head is pointing to the node that we want to delete, we would have head point to the next one, but of course this card is pointing to the one that we want to delete, and we'll do so, and then we turn true from there. We are just going to delete the first one that we discover. Otherwise, we will iterate through the linked list using an iterator. We would then check if this card is pointing to the data that we are looking for. If yes, then we would set the before pointer to the one after, and then we would delete the node that this card is pointing to and return true. Otherwise, at the end, if we haven't found anything, we haven't returned true, it means we have to return false because we couldn't find it. And when does it stop? It stops when this card, that arrow next, is pointing to null pointer, right? So we have to consider also the case when the head is pointing to an empty linked list. So we'll see if it works in our algorithm naturally. I already put together the test case where I would be, or we would be, trying to remove a record that is not there, and then we would remove all the nodes, and then try to remove from a empty linked list and see what happens. Yeah, pretty good test case. And then in the implementation, I already copy and paste the mechanism, so we are going to start coding. First of all, we need pointers. We need the discard pointer. We'll set it to head because we are going to work on just the first case where we are checking just if the head pointer or the head is pointing to the record that we are looking for. So we would just check that case first, and we are going to check. So the first thing we want to check is that head is not pointing to a null pointer. And if it's the case that is not pointing to a null pointer, then it will continue to evaluate the next condition. Like I said in another video before, the second condition would not be evaluated, and so that would not be a problem if we try to get I guess it's discard arrow data. So this statement would not be evaluated if this is not true. So I guess for the purpose of making this clear, or maybe we don't actually, this may be clearer. And so maybe we actually don't need that discard here. So anyways, we will check if it's equal to target data. If it does, then we found what we are looking for, and we are going to have, or we actually, discard equals to head is needed in this case. Okay, let me finish this first. So I feel this is better for some reason, and so it just seems to be more organized. So, and then I would have head will equals to where this card is pointing to the next record, basically after the discard, right? So it changed the hash value, and then now this card is pointing to that node that we want to delete. So we would, sorry, I keep typing the wrong words. So let's check. I think that looks right? And then we will return true. So we return that we already found the record. So if not, let's use the iterator. Node pointer iterator. So iterator actually is the before. That's what we decided to do. And we have it equals to head. And if before is equals to node pointer, it should stop, but before it should not stop. We'll check the condition later on also. And then before will equals to before arrow next. That's the iterator part. And so inside the iterator, we should set the discard. The value of discard will equals to before arrow next. And if there's condition again, so we want to make sure that discard is not equal to null pointer also, because we need to check the data that's inside the node that is pointed to by discard is if it's not null, if that node actually exists. So we are basically we are doing exactly the same thing here. We are checking if discard is pointing to null pointer, and if not, then you should go on and check if the data that it's pointing to is equal to target data. If it is, then what are we going to do? We will have before the next that is inside the before node that is pointing to equals to discard node. So that's why the node is useful. And then we would then delete the discard, because now we are secure. We have the pointers pointing to the right place and skip the middle one. And then we will return true. So and then if the whole for loop is done and we are still not finding the record, finding the data, we would say then return false. And let's check the case when if head is equals to null. This actually will go through, and then we'll go here. And then if the head equals to null, before will equal to null, and then it will fail this, and then it will return false, which is the right thing. What if, so the case when the first record is what we are looking for is taken care of, what about the last case, right? So let's see. So it means that discard equals to before no, actually discard arrow next will equal to null pointer in that case, when the last one is the one to be deleted. And so we will come in here though, because discard is not pointing to the null pointer, it's discard arrow next is pointing to the null pointer. And so this will go through, it will actually return true. And earlier on we already verified that the last pointer will actually be set to equal to null pointer. And so this should work. So let's do the test and see what happens. Let's save it. And let's compile it, clean up, run it. So it looks like, no error comes out, no segmentation for. If you see segmentation for, it means your program actually have some problems. So what I'm looking for is to check the main function. So you see that we insert 10, 9, 8, and that's why we print out is 8, 9, 10. I'm trying to remove 20. So inside the remove 20, it printed out because interesting. I see. So I compile the solution. Let's see. Yeah, so this is cleaner. 8, 9, 10. And inside the remove, or we see out the fail or false and or true. So it returns 0 because it's false. You couldn't find the node that has the record 20 or data 20. And so it print notes again is exactly the same. I didn't do anything bad to the linked list. When we try to remove 10 and then, so the last one first, it didn't give me any trouble. It returned true, which is nice. We remove 8, which is the first one. Want to test that case also, and it seemed to remove okay, and the linked list become 9. And now after we remove 9, it has nothing in it, and then we attempt to remove 20, which is there's nothing, and it's an empty linked list, and nothing happens. And so the last pre-note has nothing, and before that it returns false. So we basically test all test cases and make sure that this function works. So this is just a copy. I think it's a good idea for you to maybe try to rewrite this function to make sure you understand how it works. Honestly, it takes a while to get used to thinking the nodes in, there's a link inside the node and how to go to the next one and so on. So give it a try. To recap, we wrote the remove node function together, and then we also have special treatment for some boundary cases that needs to be taken care of, and we make sure everything is working. Next, we are going to talk about a node class. See you in next video.